Welcome back to part 2 of solving with our application problems. Okay, number 3. So in the last video, I challenged you to go ahead and try this one, and let's see how you did. So number 3, the measure of the supplement of an angle, geometry term, better remember those, is 20 degrees more than 3 times the measure of the original angle. Find the measure of the angles. Okay, so similar to how we did number 1, we have two things that are working off each other. So we have one thing, and then we have something else that's being manipulated from that thing. So in this case, I'm going to go with A, which is going to represent the original angle measure. Okay. And you could have used anything, but really the biggest letter we don't want to ever use in setting up a variable is O, because it'll look like a 0. So O we don't like to use, or I, and that's just because I means something else in math. So we have A equaling our original angle measure. Now the other measure is 3 times the measure more 20 degrees. So how would that represent? 3 times the measure plus 20. So this would be the supplement angle measure. Okay, and so hopefully when you see supplement angles, you are remembering your geometry vocab. Okay? And so supplement means when two angles add up to equal 180 degrees. So that means these 2 degrees, A and 3A plus 20, should be added together and set equal to 180. Okay, did you get that? Right. If you did, good job. If not, feel free to edit. Okay, I'm going to go ahead and encourage you to pause here and continue solving if you need to make changes. Awkward pause for you to do it. Okay, hopefully you paused it, and let's talk about how we should do it. So we have A plus 3A plus 20 equals 180. We're going to combine like terms. I'm going to subtract the 20. I'm going to move over here. 4A equals 160. Divide by 4. And therefore A must equal 40. So the original angle measure is 40. Now, what's my unit? On my last problem, I didn't have a unit. Well, in those problems, it was just a number. Okay, I'm just finding an integer in general. But here I'm finding an angle measurement. So therefore, this should be 40 degrees. Okay. Then I'm going to go ahead and substitute 40 back into my other expression to solve for the supplement angle. So 3 times 40 plus 20. 3 times 40 is 120, plus 20 is 140. Okay. You also could know that mentally that it's 140, because if this angle is 40, remember it has to be supplement to equal 180. Okay, and although you can do mental math, which we all hope you can, we also need to see your thoughts on paper. And that's because when we're grading or observing your work, I can't know what's in your head, right? So I need to see what's in your head. And that's why we show our work. Okay, we got one more problem. Okay, and this problem is number 4. Okay, make sure it's on the screen there. 2 planes leave at the same time One flies east, the other flies west at twice the speed. After 3 hours, they're 2,700 miles apart. How fast was each plane going? So in order to solve a problem like this, we need to remember our distance formula. Okay? So we need to remember that distance equals the rate at which you were traveling multiplied by the time you were traveling. So depending on how fast you're going and how long you're traveling at that speed will determine how far you go. So we have our eastbound plane and our westbound plane. So the east one is our original one. So I'm going to go with R equals the rate of the eastbound plane. And then the other one is flying twice the speed. So not 2 more, but twice the speed. Okay, so 2 times the speed. So 2R represents the rate of the westbound plane. So for this equation, we have setup and solve in the same area, but we're just going to put our equation here. So for my equation, I need to know the distance of each individual plane and set it equal to the total distance. Okay? So I have the east plane distance plus the west plane's distance equaling the total distance. Okay, so I have to figure out each plane's distance. So the east plane's distance is, again, rate times time. Well, do we know how long they've been traveling? Yes, but for the equation, remember, we don't want to put all of it in just yet. We want to show our work. So this would be rate times time plus rate times time, and it's going to equal the 2,700. We already know what that is. Now let's fill in what we know about the rate and the time. So the rate for the east plane was just rate, right? But how long was it traveling? Let's go back to the word problem. And it says after 3 hours. So they're traveling for 3 hours. So plus, well, what's the rate of the west plane? Well, the rate was 2R. Was it also traveling 3 hours? Yes. And so again, all set equal to 2,700. So if I simplify that, do we write R3? No, we always write the numerical value in front of the variable. So 3R plus 2R times 3, which would be 6R. Okay, and so from here, we're going to go ahead and say that this is my equation, because we have the east plane's distance, which is 3R, plus the west plane's distance, which is 6R, set equal to 2,700. And it makes sense to leave it like this because we can see the two different things that we're solving for. We have the east and the west plane. Now down here where I'm actually solving, I'm going to go ahead and combine like terms. So 3R plus 6R is 9R, and set that equal to 2,700. And we're going to divide by 9. And my rate is 300. 300 what? What are we talking about? How fast the plane is going. So therefore my eastbound plane is traveling 300 and miles per hour. Okay. And our westbound plane is twice that, so 2 times 300, which is 600, so therefore it's traveling 600 miles per hour. Okay. And that is how you solve number 4. Okay. Okay. You are now done with your notes and you may start your assignment.